So let's do this problem, okay? Find the power supplied by the 10 volt source in the network, right? So what is the meaning of the power supplied by 10 volt source power? So here this is the 10 volt sources over here, and they're asking us to find the power supplied by this 10 volt source. We all know that the equation for power is V into I. So V is already given, that is 10 volt. So what you need to find is the current. So current means the current through this branch, which means you need to find the node voltage V1 and V2, okay? And why are we applying node analysis? What happens if we apply mesh analysis? Okay, you see, you can apply mesh analysis, but remember, if you are going to apply mesh analysis, then this problem, then remember that this is a current source. If this is a current source and this current source is coming in between two meshes, which means this big mesh is actually a super mesh. Okay, so if you are going to do this problem using mesh analysis, don't forget this is a super mesh analysis, not an ordinary mesh analysis if you are doing mesh analysis. Okay, but I suggest you use node analysis, because here if you look at this equation, there are how many mesh analysis are there? See, 1 2 3 4 meshes, right? But if you look at the number of nodes, there are only two nodes, V1 V2, which means you need only two equations. That is why node analysis is preferable in this kind of a problem. Okay, unless and until if you are confident in doing node analysis is always better. Okay, if you are not confident, then I suggest you try with mesh analysis. Okay, so since this chapter what we are doing is node analysis, let's do it in terms of node analysis, right? So how do we apply node analysis in this circuit? You can see over here, this is a dependent source. V3 is a dependent source, which means it's better you just express this equation V3. That's all. Simply express this equation in terms of write the equation of V3. Okay, so what is V3? V3 is the voltage across this resistor. Now this is a little bit tricky for you to understand. What is the voltage across this resistor? What is the value of V3 in terms of V1 and V2? How do you write the equation for V3? You see, I want you all to write the equation of V3 without my help. Try to pause this video and try to write the equation of V3, the voltage across this resistor, and see if your answer is correct. Okay, so see, now I'll just tell you how to find the voltage across V3. It's a little bit tricky. It's not difficult, it's very easy, but you need to understand the concept. Okay, this concept I have already told many times, right? That there's only one concept, and that is current always flows from a higher potential to a lower potential. That is one thing you need to understand. Current always flows from a higher potential to a lower potential. So if you want to find the value of V3, we need to find which is the higher potential, which is the lower potential. Which side of the resistor is the higher potential, which side of the resistor is the lower potential. Because we know that current flows from a higher potential to a lower potential. So here you can see that the resistor, this plus, the V3 is marked in this order. Here it is the plus sign, and here is the minus sign, which means this end of the resistor is the higher potential and this end of the resistor is the lower potential, which means the current is going from left to right. This is the direction of the current through this resistor. That's what this V3, the sign of this V3 means. Current is flowing from left to right of this resistor. That is why it is plus and minus over here. See, because current always flows from a higher potential to a lower potential. Okay, so in that case, so this is all you need to understand. And second thing you need to understand is that we know that positive terminal of a battery always generates current. Remember that also. Okay, the positive terminal of the battery generates current. So these two concepts you just need to understand when you're going to write the equation of V3. Okay, so let's see what is the equation for V3. Let me first draw this. Let me just draw this branch. Okay, one more time. I'll just draw this branch one more time just to show you how to write the equation for V3. Okay, or equation of any voltage for that matter. Right. See, this is the branch. Okay, this is called as V1. This is the 4 ohm resistor, and this is the V3. Right, plus minus, and this is V2. Okay, and this is the 10 volt. Let me mark that also. This is the 10 volt. Okay, so now what is the equation for V3? That's what I asked, right? What is the equation of V3? So you see, since I already told you that this is the higher potential, this is the lower potential, then you can say that one thing is correct. One thing is straight fact, that V1 is positive and V2 is negative. That means the equation for V3, there'll always be a positive V1 and there's always be a negative V2. Why? Because this is plus and this is minus, which means this end is the higher potential and this end is the lower potential. Okay, this is the higher potential, this is the lower potential, which means V1 is positive, V2 is negative. That much you have understood. Okay, now so this V1 minus V2. Now what about this 10 volt over here? Is it plus 10 or is it minus 10? That you should understand, whether it is plus 10 or minus 10. To understand that also, simply look at the direction of the current. Like I said, this is the higher potential, this is the negative potential, therefore the direction of the current, like I said, it is from left to right, right? Now if you look at this 10 volt source over here, if you look at the direction of this current, this direction of the current is given in the question, and if you look at the position of this 10 volt source, this positive terminal is actually generating this current, or it is supporting this current, right? Which means, because the current always flows in this direction, right? Current is flowing in this direction, it is leaving the positive terminal and it is coming back into the negative terminal. So therefore this battery over here is actually generating current, or it is supporting the flow of current, therefore it is plus 10. See, that is what you need to understand. So this is plus V1, this is plus 10, and this is minus V2. Or in other words, the equation for V3 is V1 plus 10 minus V2. This is the voltage across the resistor 4 ohm, or this is the equation for V3. V1 plus 10 minus V2. See, this is how I understand the equation. This is how we express the equation. Okay. Let me give you another scenario. Then just let me give you another case. Okay. What happens if you get this kind of an equation somewhere? For example, okay, if you see this kind of a branch anywhere, that is, this end is V1, this is 10 volt, and this is 4 ohm, okay, and this is also, the rest is the same. Okay, rest is the same, only difference is that the battery is reversed. Okay, so here in this case, what will be the equation for V3? What is the equation for V3 in this case? What is the equation for V3 in this case? Can you tell me? So here you can see that this is the positive higher potential, this is the lower potential, which means V1 is positive, just like this, V1 is positive, and just like this, V2 is also negative. So V1 is positive, V2 is negative. That is same, right? Because this is the positive potential, this is the negative part. This is the higher potential, this is the lower potential, which means the current is flowing in this direction, correct? The current is flowing in this direction. Okay. So since this current is flowing in this direction, or if this current is flowing in this direction, which means here also the current is flowing in this direction. So here you can see that the current is actually entering the positive terminal and it is leaving the negative terminal, or this current is opposing the battery, or this battery is opposing the flow of current. So therefore this battery is negative. This battery is negative voltage, which means your equation now is V1 minus 10 minus V2. V1 minus 10 minus V2 is the equation of this branch, or is the equation of V3. Okay. Now likewise, let me give you another scenario. Okay, just so that you will not have any confusion. Suppose if the resistor is like this, and suppose if it was like this. Okay, this is the position. Okay, just assume here it is V1, here it is V2. Okay, and this is the form. So which means what I did, I just simply reverse the position of the resistor and the battery. Okay, so in that case, this is how much, 4 ohms. Okay, and the voltage across the resistor is also plus V3. Here it is 10 volt. Okay, 10 volt. Okay, so what is the equation for V3 over here? What is the equation of V3? So here, just whatever it is, just think exactly like how I told you, right? So here, this is the positive terminal, this is the negative. So this is not positive terminal, this is the positive potential, this is the higher potential, this is the lower potential. So this is the higher potential, that means V1 is positive, and since this is the lower potential, V2 is negative. So V1 is positive and V2 is negative. Okay, now what about this battery? Is this battery supporting the current or against the current? Let's see. Since this is a higher potential, this is the lower potential, the current is flowing from a higher potential to a lower potential, right? So this is the direction of the current. So if you look at the direction of this current, you can see that the battery is actually supporting this current, because this positive terminal is generating the current. Because the current is leaving from the positive terminal, which means this positive terminal is generating the current. Therefore, it is plus 10, which means it is V1 plus 10 minus V2. See, V1 plus 10 minus V2. If you simply look at these two equations, it's actually the same. Simply look at these two, the value of V3 is actually the same, because reason is because no matter where you keep the battery, it all depends on the position of the battery. Whether the position means the sign of the battery. It does not depend whether it is before the resistor or after the resistor. The voltage across the resistor remains the same irrespective of the location of this voltage source. You see, it's only the position that matters. That's why these two equations are the same. Likewise, one more case also, if I can draw with that, right? So here this is the resistor, and I'm drawing this thing like this. This battery is like this, and this is the 4 ohm resistor. This is the 10 volt, okay? And here this is the positive potential, this is the higher potential, this is the lower potential. This is V3, this is V1, and this is V2, okay? So in that case, so let's see. In this case also, like I said, since this is the higher potential and this is the lower potential, V1 is positive and V2 is negative. And is this 10 volt positive or negative? Let's see. Since the current is flowing in this direction, right? From left to right, since the current is flowing in this direction, this current is actually entering the positive terminal, or which means this positive terminal is not generating current, it is opposing the flow of current. Therefore, this battery is negative, which means V1 is positive, V2 is negative, and this 10 volt is also negative. Or in other words, V3 is equal to V1 minus 10 minus V2. This is the voltage across this resistor, or the equation for V3. Okay, and if you look over, like I said before, if you look over this equation and other equation, yeah, this equation, these two equations are basically the same, right? These two equations are basically the same. The only difference is the location of this voltage source. This voltage source is coming before the resistor, this voltage source is coming after the resistor, but the position of the voltage source is the same. See, so it doesn't make any difference. So this is what you need to understand when you're writing the equations, okay, of learning to write the equations, right? You should be able to learn to write any equation like this. If you have any other doubts, you can contact me, you can tell me, okay? If you have any other different scenarios, okay, you can just ask any doubts, you can ask me. So now let's do this question, all right, based on node analysis. So which means here I'm going to apply the equation for node V1. So here I have already expressed the equation for V3. Let me write the equation for V3. The equation of V3 is equal to V1 plus 10 minus V2. Okay, this is the equation for V3. V1 plus 10 minus V2. So now let me write the equation for node V1. So equation for node V1. Equation for node V1. Okay, so you can see that in this V1 there is a current through this branch, through this branch, through this branch, and through this branch. Okay, which means 1, 2, 3, 4. There are 4 branches, which means there should be 4 terms. And what is the first term? The first term is, the name of this current is already shown over here. It is 10 amperes and it is going outwards, right? Same direction as the arrow mark. So which means it is plus 10. So the first term is 10, okay, plus, what about second term? Here it is the current across, this is voltage across resistor divided by its resistance, or this is V1 minus 0 by 2. V1 minus 0 by 2, or V1 by 2. V1 by 2, okay, plus, now what is the current through this branch? The current through this branch, oh, that's easier. I just told you the voltage, right? Same thing. So what is the current through this branch? It is V1 plus 10, because since why does V1 plus 10? Because like I told you before, the current is flowing outwards, right? So since the current is flowing outwards, this positive terminal is generating the current. See the same, look at the direction of the arrow mark. it is flowing like this, which means this positive terminal is generating current. So it is V1 plus 10 minus V2, right? V1 plus 10 minus V2. So it is V1 plus 10 minus V2 divided by 4. This is the current through this branch. Voltage across this branch is V1 plus 10 minus V2 and divide by its resistance. Resistance is 4 ohm. Okay. So now I wrote the current. I wrote the current through this branch. Now next is this one, right? What is the current through this branch? Here it is flowing from V1 to V2, which means V1 is the higher potential, V2 is the lower potential. So it is V1 minus V2 by 2 plus V1 minus V2 by 2. Okay, V1 minus V2 by 2. 1, 2, 3, 4. 1, 2, 3, 4. Okay, this is it. This is the Kirchhoff's current law, right? So now let me express this in terms of V1 and V2. So we will have over here as V1 into, so we see where is the V1? Here it is V1 1 by 2. V1 is over here plus 1 by 4. Then there is V1 over here also, there's plus 1 by 2. Okay, 1, 2, 3, right? Only these three cases. So this is the value of coefficient of V1. Next is I'm going to write the for V2. Okay, what about V2? Let me see. V2 is over here. This is what I have already wrote plus over. So this is minus 1 by 4. Minus 1 by 4. And what about over here? Here also there is minus 1 by 2. Minus 1 by 2. Okay, minus 1 by 2. There you have it, right? So this is minus 1 by 4, this is minus 1 by 2. There is no other V2 over here, right? Only this one and this one. Okay, this is equal to, now what about the source? Here you have a 10, so that will become minus 10. And here you have 10 by 4. 10 by 4 is 2.5, right? So this is 10 by 4 is 2.5. So when you come over, it will become minus 2.5. Minus 2.5. Calculation on I leave up to you. You can do it in your own way. Okay, you don't have to follow this. Just make sure that the equation is correct. If the equation is correct, then no matter how, in what form you write, you will always get the correct answer. Okay, and the rest is up to practice. So here let me see, this is 0.5. This is also 0.5. 0.5 plus 0.5 is 1. This is 0.25. So this is 1.25, which means this is V1 into 1.25. You don't need to calculate for that. And what about this one? This is 0.25. This is 0.5. So this is 0.25 plus 0.5 is how much? 0.75, right? So this is minus 0.75. Minus V2 into 0.75. And this is minus 12.5 is equal to minus 12.5. You don't need a calculator for this. Alright. So this is the equation. This is the equation. First equation, right? Now let's write the second equation. Equation for node B2. Equation for node V2, right? Let's see. This is the equation V2, so which means I'm going to assume this direction is like this. All the directions of this junction are like this. Okay, all in the opposite direction, right? So let's start. Which one you want to write? All right, first I'll write this one, this branch. Okay, so what is the current through this branch? The current, which means here you can see this is the direction that you have assumed, right? So and you know the current always flows from a higher potential to a lower potential. Therefore V2 is positive and V1 is negative. V2 is positive and V1 is negative. Alright, that's the first thing you understood. Okay, now what about this 10 volt? Is this positive or negative? You see, like I said, the direction is going like this, right? It's going from right to left. It is going like this, or it is going into the positive terminal, which means this positive terminal is not generating current, it is opposing the current. So therefore this 10 volt is also negative, which means V2 is positive, 10 volt is negative, and V1 is also negative. Right, V2 is positive, V1 is negative, and this 10 volt is negative. Or the voltage across this resistance, assuming this is the direction of the current, the voltage across this will be nothing but how it is, V2 minus 10 minus V1, right? V2 minus 10 minus V1, because this is positive, this is negative, and this is also negative. That is why V2 minus 10 minus V1 by 4. So this is the current through this branch flowing from V2 to V1. Okay, plus now What is the current through this branch? Flowing from V2 to V1. Since this direction is going like this, which means V2 is the higher potential, V1 is the lower potential, right? So therefore, V2 minus V1 by 2. That is the current through this branch. Now, what is the current through this branch? See, here you can see there is a current source over here, right? There is a current source over here. And what is the equation and what is the value of the current source? 4V3. 4V3 is the value of this current source. This is actually voltage controlled current source, right? Voltage controlled current source. So what is the direction of this V3? Is it outgoing or is it incoming? It is incoming. See, it is going into the junction, or in other words, it is opposing your current. See, you assume that the current is in this the current in this branch is in this direction, but this current is going upwards, opposite to the one that you have assumed, which means this is minus 4V3. Minus 4V3. Okay, so the current in this branch is minus 4V3. Okay, now what is the current through this branch? Here it is V2, here it is 0, so it's V2 minus 0 by 1. V2 minus 0 by 1 is V2 by 1, or this is plus V2 by 1. Okay, now I need to write by 1. Okay, this is equal to 0. This is the Kirchhoff's current law of this junction. Okay, so now I'm going to express this in terms of, oh, one more thing. Here there's V3, right? Like I said, if there is a dependent source, what you need to do is you replace that with the actual equation. What is the actual equation? V1 plus 10 minus V2. So put that over here. Then you write it in terms of V1 and V2. That's the easiest part. So let's see. V2 minus 10 minus V1 by 4 plus V2 minus V1 by 2 minus 4 into, so this is nothing but V1 plus 10 minus V2 plus V2 equal to 0. This is the equation. Okay, so now I'll separate this in terms of V1 and V2. Okay, first I'll write in terms of V1. So it will be V1 into, let me see, here V1 is over here, right? What is this? This is minus 1 by 4. Minus 1 by 4. Here also there's V1, this is minus 1 by 2. Minus 1 by 2. And here also there is V1, it is minus 4, right? Minus 4, okay. And that's it, no other V1 is over here. So this is the coefficient of V1. Next I'm going to write in terms of V2. What about V2? V2 is, let me see, one V2 is over here, that is 1 by 4, right? Here it is 1 by 4, here it plus 1 by 2, and here it is minus of minus becomes plus. So here is also plus 4, right? Plus 4. Oh yeah, here is one more thing also, plus 1. So it's plus 1, right? There you go. This is equal to, now what about the remaining values over here? What do we have? This is minus 10 by 4. Minus 10 by 4 means minus 2.5, which means over this side it will become plus 2.5. Then what else do we have? Yeah, here you have minus 40, right? Minus 40. So this will become plus 40. So this will become plus 40. No other source. That's it. This is the equation. Alright. So let me see. What is the equation for V1? V1 into, what about this? This is 0.25, this is 0.5, which means this will become 0.75, and this is 4. So this becomes 4.75, right? Minus 4.75, right? Minus 4.75. And what about this case? Here this 4 plus 1 is 5. 5 plus 0.5 is 5.5. 5.5 plus 0.25 is 5.75, which means this is nothing but V2 into 5.75 is equal to, what about this? This is 42.5, right? 42.5. There you have the equation. Okay, so now solving these two and you can find the values of V1 and V2. Okay, so let me write this equation one more time. 1.25 V1 minus 0.75 V2 is equal to minus 12.5, and the second equation is minus 4.75 V1 plus 5.75 V2 is equal to 42.5, right? Now let me see what magic I can do to make this thing, easier. If you look very carefully, right, this entire thing is actually divisible by 25, right? This entire equation is actually divisible by 25. Correct? Yeah. Everything is, yeah, all these are divisible by 25. Don't say 25. I think I'll say 0.25. Yeah. Divide these two equations by 0.25. Let me see what will happen. Divide these two equations by 0.25. What is 1.25 by 25? You don't have to look at this video. You don't have to look at how I'm doing. Okay, you can pause this video and try and do the rest of the rest of the procedure by yourself. Okay, I'm just doing it in my own fashion. So this is 1.25 divided by 0.25. What do I get? 5. So this is basically 5v1 minus 0.75 by 0.25 is 3, right? So this is 3v2 is equal to minus 12.5. Let me see, 12.5 divided by 0.25 and you will get is 50, which means this is minus 50. Okay, now what about this one? This is 4 points. What is 4.75 divided by 0.25 and you get is 19. So this is 19v1 or minus 19v1. Okay, and plus what about this 5.75? Let me see, 5.75 divided by 0.25 and you get is 23. So this is 23 v2. And what about this 42.5, right? 42.5 divided by 0.25 and you get is 170. Yeah, I think this is much easier, right? Dividing it by this value, I think is much more easier. So now I think you can solve this using any technique you want. I think I will multiply this equation into I think I'll multiply this into 23 and I will multiply this equation with 3. Okay, so if I multiply this into 20, so these two will cancel each other, right? So this will become, let me see, what is 23 into 5? 1115. So this is 115v1 minus 23 into 3 is 69 minus 69v2 is equal to 15 to 23 is 1150 minus 1150. Okay, now second equation, 19 into 3 is 57 minus 57, so it is minus 57 v1, and here it is plus 69 v2 is equal to 170 to 3 is 510, right? 510 there. So now I can add up these two equations. So adding up these two will get cancelled, and this is nothing but 115 minus 57, 58. So this is 58 v1. 58 v1 is equal to minus 1150 plus 510, and you will get is minus 640. Minus 640. In other words, v1 is equal to minus 640 by 58. Minus 640 by 58, which is equal to 640 divided by 58 is equal to 11.034. 11.034. Let me see. Correct, right? Yeah, it's correct. Minus 11.034. So V1 is equal to minus 11.034 volt. Okay. So now I can find the value of V2. Let me see the value of V2. Which equation I'll use? I think I'll use this equation. This equation looks much more easier. Right. So this is 5V1, or this, and therefore equation for V2. Right. What is the equation for V2? This is 5V1 minus 3V2. Or let me see. 5V1 minus 3V2. 5V1 minus 3V2 is equal to minus 50. Right. 5V1 minus 3V2 is equal to minus 50. Or in other words, minus 3v2 is equal to minus 50 minus 5v1, or in other words v2 is equal to 50 plus 5v1 minus by 3. Okay, so which means it is, let me see, here it is 50 plus 5 into minus 11.034, minus 11.034. Okay, 11.034, close the bracket again, divide by 3, and you will get is minus 1.723. Let me see if the answer is correct. Where it is? Yeah, it's correct. Minus 1.72. So this is minus 1.723 volt. This is the equation for V2. Okay. So therefore, in that case, now I can tell the, so what I need to find is the power, right? The power through this branch, right? So if you need to find the power, you need both the voltage and the current. Voltage, I know it is 10 volt. Now what is the current? So I just need to find the current, right? So current through the 10 volt source. Current through the 10 volt source. 10 volt source. Okay. And that is equal to the current voltage across it is, like I already told you, voltage is nothing but V3, right? Or V1 plus 10 minus V3 is the V3 by 4. V3 by 4, or in other words it is V1 plus 10 minus V2. V1 plus 10 minus V2 by 4, or in other words, what is V1 is minus 11.034 plus 10, and this is minus of minus becomes plus, so this is plus 1.723 by 4, which is equal to, let me see, put a bracket, minus 11.034 plus 10 minus, no, minus of minus is plus, plus 1.723, close the bracket, divide by 4. Let me check if I typed correctly. Yeah, okay. So this is equal to 0.172 amperes, which means now I can tell you the power, right? So the power supplied by the 10 volt source is equal to V into I, which is equal to 10 into I is 0.172, which is basically, this is equal to 1.72 watts. This is the current, or sorry, this is the power supplied by the 10 volt source. Let me check if the answer is correct. Yeah, 1.72 watts. Okay.